Hey class, back with another quick one here about algorithms. You guys have actually already used algorithms. If you remember back to the first unit, you did an assignment called pseudocode fun or something like that, where you actually created created a couple algorithms for some everyday tasks. Now, we use algorithms as people all the time, whether we're thinking like, "Oh, I'm doing an algorithm" or not. We use them, and that's because all an algorithm is a set of clearly defined logical steps to solve a problem. Um, so I know we hear a lot. We use the word algorithm in a lot of different ways, especially I think a very common use is when the internet just gives you that one thing that you've been looking for, even though you didn't tell it you were looking for it. The algorithm it knew what I needed or whatever. But really, an algorithm is just again a set of steps that solves a problem. In computer science, we use these all the time, whether we're programming or trying to create a web development project. There could be 100 different ways that we use them. A big one is in searches. As we generate a lot of data and we use computers to store that data and be able to find that data, we want to be able to find it efficiently, right? And if you imagine, let's say you have a big pile of stuff that you have to dig through to find different things that you're looking for. A good way to make that easier would be to sort the stuff, maybe in groupings or in like in order from smallest to biggest. You could think of a bunch of different ways, but it doesn't really matter. As long as we sort it, it's immediately going to make it easier for us to find. A really good example of this is I like to play Magic the Gathering, and each Magic card has a cost attributed to it. And so I've sorted a lot of my cards by cost so that I can say, oh, that card costs 3 mana. I'm going to go look in my 3 mana spells to go find it. You're getting to see how nerdy I am. But it makes it easier to go find that, and so computers do the same thing. We take our data and we sort it in certain ways, and to make it easier to find. Now there's a couple of different kinds of searches that we can do. You can start at the beginning and just go from left to right, smallest to largest. Now obviously that might or like alphabetically, for example, we could do a search like that, and that might be efficient if we know what we're looking for starts with an A, right? As we start at the beginning of the alphabet and move through, we'll find it pretty quick if it starts with an A. But let's say I'm starting to search for things that maybe they're after the second half of the alphabet. That's not going to be as efficient, right? If I have to go all the way back to the beginning and do A again all the way through to the M's or whatever, and then, I got another name, I got to go back at the A and go all the way through. It would be better if I could search more specifically. So again, this is where the groupings or the sorting helps us. We have other ways to search. We could do what's called a binary search, where we start in the middle and we say, is my value greater than or less than? Is it on the right or the left? And then when we know, we go to the middle of the right if it's on the right, and we do that again, and we cut it in half, and we cut it in half, and we cut it in half until we land on what we're looking for. And that's more efficient, right? Or we sort it into groupings, and we know my data is part of this subset or this group. And so instead of searching through all of the stuff that I have, I'm going to look for the group type in amongst the groups, and then in that group I'm going to look for my bit of data or my different thing. And so you can see I'm setting out a set. I sort my data, I understand the sorting of it, and then I search accordingly, which saves me time instead of having to grab one thing at a time and take a look at it. Another real world example, my kids have a toy room, right? And we have way too many toys. This is what you get when you have little kids. My wife's solution was to get different bins, and we put the different types of toys in each bin. And so when my son wants a Hot Wheels car, he just goes to the car bin and he finds that Hot Wheels car. And then when my daughter wants, a Barbie, she can go to the Barbie bin and find it, which is a great idea in practice, or in theory, but unfortunately in practice, a 2, a 5, and a 7-year-old don't put things back in the bin. So my solution was to dump all the toys into this gigantic, like 50-gallon bucket thing that I bought at Home Depot because I was tired of having to resort them every time we cleaned, and I'm tired of my kids not sorting them. The first day of having that, my daughter, my 5-year-old, looked at this and said, this is terrible. You can't find anything in here, because she's having to dig through the whole thing. She's having to go through every single toy. Now, in this case, I didn't feel that bad because they never put them away anyway, and this was way easier to clean up, and I do a lot more cleaning than sorting now. But in computer science, we do similar stuff. You can take all your files and all your schoolwork and everything and dump them in one file, and make it hard to find anything, or you can organize it. You can sort it so that when you go to search for it, it's easy to find. And you can set up those algorithms, those steps to go through and complete those tasks that you're looking for. Now, in terms of programming, every code that we write is going to be an algorithm. We're going to want to look at step number 1 is this, and step number 2, 3, and 4 to solve whatever problem we're trying to solve. Whether that's I'm trying to make it so when my player hits the space bar, the little avatar jumps, or I'm getting login information from a user, or I'm just calculating some math. Either way, we have a series of steps that we're going to follow. And so those algorithms are going to become very, very important as we get into more of the programming. And you'll be using them like crazy. And so, I think you'll find you don't have to think to yourself, I'm going to write an algorithm. But think, what are the steps that I need to take to complete this task? And as you break problems down, especially some of these computer science assignments, you'll break them down into smaller pieces and just attack each step one by one, and you're creating an algorithm. So super straightforward.